Good morning, students. We will continue magnetic effect of current questions. See, you are given one figure. It is one very long wire which is placed in y direction carrying current I1. On x-axis, another wire carrying current I2 having length L is placed at a distance A from origin or from this wire. Your question is, what is torque acting on this wire with respect to point O? That is your question. Okay. Now, what is equation of torque? Torque is equal to, its definition is torque is equal to R cross F. R, that is position vector, and F, that is force. So, see, as we have to find with respect to O, torque for this wire, then R cross F, R, that is position vector. What is position vector? What we have to consider? A or A plus L, because it varies from this one end to another end. Also, as this wire is like this, okay, force from this wire as distance changes, magnetic field changes and magnetic force changes. So magnetic force is not constant over the entire length. So which method we have to adopt? Okay, yes, we will take method of integration. We will take method of integration, and for that I am first of all assuming that this wire, it is made up of number of elements. From that I am getting one element, okay, this element of length dx at distance x from origin. At distance x from origin. Okay, so here I have to write, take one element on second wire at distance x having length dx from O. Okay, so first of all we will find what is torque acting on this element due to this wire with respect to point O. Then to find total torque we will integrate it. Okay, so to find torque, first of all we require position vector and force. For force, first of all we have to find what is magnetic field at this point. So yes, first of all I will find what is magnetic field at this point. So first step is to find magnetic field at distance x due to wire 1. Wire 1 means this one. It is wire 1. Due to this wire, what is magnetic field at this element? Magnetic field at distance x due to wire 1 at element. So what is the equation of magnetic field? I will write here it is dB. So dB is equal to, due to long straight wire, what is the equation of magnetic field? Mu 0 I upon 2 pi r. Here I will get mu 0 I1 upon 2 pi x. Distance is x. Now what is direction? To see, it is simple. Current I1 is going in upward direction. Element is in this direction, like this. So thumb is going inside. Going inside, it is x-axis, it is y-axis, z-axis is perpendicular outside. So inside direction means minus z-axis. So here I can write it is minus k. Magnetic field at this point. Again, I1 in this direction, wrap fingers towards this direction because this element is towards in this direction. So dB is towards mu 0 I1 upon 2 pi x minus k. Now, see, we have to find what is force acting on element. So first of all, current element of given or assumed element. So how to write current element? Yes, I can write EI. is equal to current element. How to write current element? You know what is current element? It is ideal. Then how to write equation of current element? Ideal. See, what is current flowing from this whole wire? It is I2. So yes, here it is I2. What is length of this element? It is dx. And in which direction current is flowing? It is in x direction. So here it is I caret. Simple. Ideal is equal to is I2 dx I caret. Now, force acting on element. Force acting on element, that is Tf, is equal to, what is equation? Equation is, it is ideal cross B. It is ideal cross B. But instead of B, I will here write it is ideal cross B. Ideal cross B. Any doubt? Okay. Now is equal to ideal cross D. Ideal, what is ideal? It is I2 dx I caret cross. What is value of dB? Here it is mu 0 I1 upon 2 pi x minus k caret. Clear about this? So is equal to, I can write this minus here. Okay, mu 0 I1 I2 dx upon 2 pi x, and in bracket here I can write it is I cross k caret. I cross k caret. Clear about this? Now what is value of I cross k caret? See here you have to remember this. Okay, if it is I caret, j caret and k caret, then I cross j is equal to k. J cross k is equal to the remaining one, that is I, and k cross I is equal to j. And if you change order, then you have to write minus sign. Here as k cross I is equal to j, you can say I cross k is equal to minus j. Okay. So is equal to, wait a minute. Okay, so yes, here it is I cross k is equal to minus j. Then how to write? See, minus mu 0 I1 I2 dx upon 2 pi x, and here you can write it is minus j. Minus, so you can write it is plus. So is equal to, it is mu 0 I1 I2 dx upon 2 pi x j caret. Okay, df is equal to this. So now, hello, numbers of steps. First of all, find what is magnetic field at this element, current element of this element, what is force acting on this element. Now we will find what is torque acting on this element. Okay, torque acting on element. Torque acting on element. What is equation of torque? Okay, d tau is equal to, it is R cross, here I will write df. Actually equation is tau is equal to R cross F. I can write it is R is equal to df. So is equal to, chalo, R. From this point, position vector, R means position vector. So from this point, what is distance of this element? X, and it is in positive x direction. So here I can write I R is equal to, it is x side. Simple. And df, that is given. Here it is mu 0 I1 I2 dx upon 2 pi x. Here it is j caret. Any doubt? Okay. Now I can write this as, to see here x, then mu 0 I1 I2 dx upon 2 pi x, and in bracket here I can write it is I cross j. So this x cut. Then what is d tau? Then d tau is equal to, it is mu 0 I1 I2 dx upon 2 pi, mu 0 I1 I2 dx upon 2 pi, and I cross j. What is the value of I cross j? It is k caret. Yes, here it is k caret. Simple. Okay. Now it is torque acting on only one element. To find what is torque acting on this whole wire, I have to find a torque acting on wire 2 with respect to point O. So tau is equal to, it is integration d term. Okay, so is equal to, it is integration mu 0 I1 I2 dx upon 2 pi, here it is k current. So I can write this as it is equal to, it is mu 0 constant, I1 constant, I2 constant, 2 pi constant, okay, integration dx, and here it is k current direction. Now integration dx means what? See, dx, that is nothing but the length of this element. We have to find what is the total length of this wire. You can put limit, or you can also write directly, okay, answer will be L, because what is total length of this wire? That is L. If you put limit, then you have to put limit A to L plus A, then A L plus A minus A will be basically A, okay. So yes, you can write it directly. It is equal to, it is mu 0 I1 I2 upon 2 pi. What is integration dx? It is L, and here it is k caret. So total torque acting on wire is mu 0 I1 I2 L upon 2 pi. K caret, that is direction of torque. Simple. So yes, you can also use this equation to solve some questions directly. Yes, it is proof actually. Okay, derivation, but you can also remember this equation directly. But why to solve this one question? To understand each and every concept. How to find direction, I cross, J cross, etc., etc., etc. Clear? So yes, it is one question. Is it visible? Okay, now it is visible. Okay, now some points to be remembered. Yes, we know that magnetic field is produced due to flow of charge, that is current. If current it is passing from one straight wire, or if it is from one ring. Also, if we have one helical coil which is insulated from each and every turn, then it is called solenoid. Okay, solenoid. So what is magnetic field due to solenoid? Okay, first, long solenoid. Okay, due to that long solenoid it means what? Okay, if length is greater than its radius, length of solenoid is greater than its radius, then if it is solenoid, long solenoid, okay, current is flowing in this direction, that is I. And if in this turn current is flowing I, means in every turn current is flowing is I, and in same direction. Okay, you have to remember, okay, K for long solenoid, outside magnetic field is equal to 0, and inside magnetic field is uniform, and it is in this direction. Actually, you have to find direction. Okay, for example, current is flowing in this direction, then magnetic field will be in this direction. Okay, so this is direction of magnetic field. If current is flowing in opposite direction, then the value of magnetic field changes. So inside solenoid, magnetic field B is equal to, its equation is this, mu 0 small n I. Why mu 0? Because we are assuming that inside the solenoid the field is air or free space. And what is n? N is called numbers of turns per unit length. Numbers of turns per unit length. Where if you are given that this solenoid having total n turns, total numbers of turns n, suppose its length is L, length of solenoid, then what is number of turns per unit length? It is n upon L. Clear? So yes, remember this equation. Okay, what is equation of magnetic field? Outside magnetic field is 0, okay, inside magnetic field is mu 0 Ni. You can say this long wire is of infinite length. Okay, yes, you can say it is of infinite length. But if you are given one solenoid of finite length, solenoid having finite length, Then for that solenoid of finite length, if it is its cross section area, okay, if you cut this solenoid like this, then it will be its cross section area. Then suppose at this point, what is equation of magnetic field? Connect two ends, it is perpendicular distance, let this angle is alpha, this angle is beta. Then at this point, what is equation of magnetic field? B is equal to, it is mu 0 Ni by 2 in bracket, it is sin alpha plus sin beta. That you have to remember. In most of cases, you will be given non-solenoid. That is of infinite, not infinite length. Okay, what is meaning of actually infinite length? Okay, if length is very greater than its radius, then it is called non-solenoid. And in non-solenoid, inside solenoid, magnetic field B is, we can say, uniform. Magnetic field B is uniform, and it is its equation. B is equal to mu 0 and it is space of finite. Okay. One more thing, another thing, toroid. What is toroid? Okay. So toroid means if we connect two ends of this solenoid, then it becomes toroid. Or if you have one ring and if wire is wound on it, okay, then it is called toroid. In case of toroid, in this region, magnetic field is 0. Outside, magnetic field is 0. Magnetic field is only in this region, that is pole. And here magnetic field is equal to, it is again mu 0 Ni. In this case, what do you mean by N? N is equal to, it is N upon 2 by R. If you are not given R, then how to find? Suppose here it is magnetic field 0. Suppose this radius is R1. This outer radius is R2. Then here we can say, okay, R is equal to, it is R1 plus R2 divided by 2. Simple. So for both solenoid and toroid equations are same. Here B is equal to mu 0 Ni. Here also B is equal to mu 0 Ni. But definition is different. Here small n, it is number of turns per unit length. That is straight object, that's why only length. Here it is circular in nature, that's why it is 2 pi r. Simple. Figure about this. If air is not medium, that air is replaced by another material, then yes, you can replace this mu 0 by mu. Here you can replace this mu 0 by mu. Clear? Okay, so yes, these 2 points you have to remember about solenoid and toroid. Yes, that is simple use of equation only. If you remember equation, you can easily solve questions. Okay, so yes, these 2 points, toroid and solenoid, you have to remember. Okay, in next lecture we will see some more questions.